Hello, today we're going to talk about the beginning of Tool 1, which is on experimental techniques, and specifically we're going to talk about some general things with some safety rules and how we're measuring different variables. So the first part of Tool 1 is addressing the safety of yourself, others, and the environment. And so you're supposed to be able to recognize and address relevant safety, ethical, or environmental issues in an investigation. I don't want this to take the place of any of your safety guidelines that are at your particular school site, which could be very different depending on your location. But some very general things that do pop up in actual questions has to do with safety things like heat. So hot glass looks the same as cool glass. Make sure that if you are heating anything, you are using appropriate safety tools to protect from the heat. We have like the red rubber hot hands. You could be using tongs or other tools that can protect yourself from burns. Another common one would be spilling anything that might be hazardous or harmful. So I'll put spills. So certain cases it might be more appropriate for you to wear gloves. But other cases, it might be more appropriate to just be very aware of if anything gets on you that you need to wash your hands very quickly. It really depends on what substances you're using and your local guidelines. Another good one would be if a reaction is producing a gas or vapor. Some cases you might need to be using a fume hood to protect yourself and others from the exposure to that gas. But again, it depends on which gas is being formed. Another thing to consider is if you need to wear any other personal protective equipment. So things like aprons or lab coats, long pants, shoes, tying hair back, keeping jewelry away. It's going to, again, be different depending on your particular lab and what materials that you're using. In any situation, you want to consider how you're going to dispose of any materials that are left over at the end of your experiment. So that's where we're getting into environmental issues. So what's going to happen if you were to flush that stuff down the drain? Or are you even allowed to do that? Do you need to be disposing of it in a completely different way? So again, I just want this to be a very general, hey, you need to pay attention to these things and make sure that you look them up, especially when you're designing your internal assessment. At least where I am for most of this, you're going to be referencing the safety data sheets. They used to be called material safety data sheets. But that will have information about safety concerns, exposure concerns, and disposal information typically. So yeah, just make sure that you are aware of this and it needs to be addressed anytime you are beginning a laboratory experiment. So now let's talk about some general considerations when you're making measurements. A big one would be the difference between accuracy and precision. Accuracy is how close you are to like the true value. So you want your measurement tools to give you accurate results. Precision, on the other hand, is repeatability. How often, like if you were to repeat the measurement over and over again, are you getting the same answer every time? Now, ideally, you want high accuracy and high precision, but that's not always possible. So keep in mind that we're looking for both of those things. I will say a really common example for accuracy versus precision is using the target. Like think archery target. These ones kind of look like Bohr models. So let's say, the target, the center of the target is your true measurement. And you could have a bunch of measurements that are nowhere near the center and they're spread out a lot. That would not be accurate or precise. You could have a very high precision, so they're very tight grouping, but not near the center. That would be precise, but not accurate. So precise. And you could also have a very tight grouping very close to the center, and that would be both accurate and precise. Now, another measurement that we want to talk about, another measurement consideration, would be validity versus reliability. And it's another way for us to talk about the quality of our measurements. Validity is how we talk about whether the tool is actually measuring what we want it to be measuring. So this could be something like, is your tool properly calibrated? So whether it's measuring what it's meant to measure. Reliability is another way of talking about repeatability. So are you getting the same result every time you measure that same thing? Now, if you're repeating a whole lab procedure, we typically call that reproducibility instead. So if you were to take a procedure written by somebody else and try the exact same experiment, and if you get the same results, then it is reproducible, which is what we would like to see in a very reliable laboratory procedure. So I want to take a minute to review significant digits, just in terms of how we record measurements. So if you were to have a digital measurement tool, you want to record all available digits. So if you have like a digital balance that goes to the hundredths place, let's say you have 9.37 grams showing up on your balance, you want to record that entire measurement. Or a digital thermometer, you want to record, let's see if I can draw a decent one. It's a temperature probe, digital thermometer. Whatever the temperature, you want to record all of the available digits. There's our thermometer. Okay, but if it's an analog device, so not a digital measurement tool, you want to record so all of the digits that you know, plus one that is estimated. So you should be estimating in between the lines. Now, some people will recommend that when your estimation should always be either to the 0 or to the half mark. So you either estimate that it's on the line or you estimate that it's halfway between the line. I've seen other people do it other ways. So just kind of keep that in mind. And let me give you a couple of examples. So if you're measuring like with a graduated cylinder, and let's say, for example, this is 10 and this is 20, and you only have lines for 10 and 20. So you could estimate that this is 15 milliliters, if this is a milliliter graduated cylinder. So that's what I mean, halfway between. You can measure it much closer, and you can say that that's like 20. But I've also seen people say that you can estimate this whole last digit as well. So you could say that maybe that's 18 milliliters. Either way, you should not be saying that it's 18.7. Like, that's too far. You know the tens place is a 1, and you're going to estimate one further place. So this measurement device, as it's drawn, can only measure 2 significant figures. Now, if I were to have individual markings in between, now I have the ability to record more significant figures. So let's say I have our liquid level is here. So I know it's between 15 and 16. I can estimate that it's 15.5. I know that it's 15 point something. I'm estimating that it's halfway to the 16 mark. So that would be 3 significant figures. So all of the marks that you know, and then one additional estimated place in between the lines. Okay, so the last part of this, we're going to talk about specific variables, and we're going to look at recording them to an appropriate level of precision. We talked about analog versus digital, and both of those things apply to all of these types of measurements. I do want to point out a few specifics, though. When you're dealing with mass, you always want to make sure that you tare the balance or zero the balance before measuring. And different balances are going to have different numbers of significant digits that are available. Typically, you'll see something like an analytical balance will have like a cage around it. I don't know what else to call it, like a shield. And that's there to prevent like air currents or dust from affecting your measurement. And usually they'll have like sliding doors. Sometimes it's a sliding lid on the top. And you want to make sure that it is completely closed when you zero. And then you will open and add your measurement and then close the doors again and wait for it to settle. And then you can record your accurate measurement. So be aware of that for mass. And again, with the digital, you want to record all available digits for your measurement. Now for volume, typically you're going to see milliliters for the amounts that you're using for a typical chemistry lab, but it could be liters. Now, one thing that I will say with volume is this word volumetric. Volumetric helps tell us that it is very, very accurate for one specific volume. And you will usually see volumetric pipettes or volumetric flasks that are very accurate for one volume only. So like a volumetric flask looks kind of like this, has one line, it measures that one volume very closely. A volumetric pipette, you'll typically see the line and then a small bulb and then your point here. And usually a volumetric pipette is just for a smaller volume than you'd have in a volumetric flask, but they are very similar. You could also use things like graduated cylinders. You can even use burettes for measuring volume, but volumetric is typically going to be more accurate. Also, when you're measuring volume, you always want to measure it from the bottom of the meniscus. And this is especially true for water-based solutions because of the high surface tension. The bottom of the meniscus should reach your line that you're measuring. So that's for volume there. Now for time, you're going to typically be using a digital tool for this. Recently, you could use an analog stopwatch. It's just not very common. Now, if you are controlling the stopwatch, there is inherent human error, and this has been asked in the past. What is the error involved with using a stopwatch is that you have to notice that a reaction has changed or that something has changed and then press the stop button. And that time difference causes a systematic error. But there are time measurements built into different measuring tools as well. So it really depends on how you're doing that. So that's time. Now, temperature depends on if you're using an analog thermometer or a digital thermometer or a temperature probe. You always want to record all of the available digits for digital and make sure that you're paying attention to the unit available. So that's temperature. Length, again, very similar. You're going to most likely be using an analog tool if you're measuring length. This is for my American students. You just want to make sure that you're measuring in centimeters and not using inches because we want to make sure we're using SI units throughout. If you're measuring pH, you will almost certainly be using a pH probe. You can use an indicator. The problem with indicators is that color is subjective, and indicators have a range of pHs in which they are changing colors. So while you can use an indicator, it's not going to give you a very accurate measurement of pH. It's just going to give you a range of values. I would recommend using an indicator or like a pH paper or litmus paper in addition to using a pH probe if possible. Now I'm going to talk about electric current and electrical potential difference kind of at the same time here. Again, you're typically going to be using a digital probe for this. Electric current is mostly you're going to be measuring using something called an ammeter, but a multimeter will have that built in typically as well. So an ammeter measures the amps. Electrical potential difference, you'll typically see, I have something called a differential voltage probe, And this is used a lot when you're doing like voltaic or galvanic cells. So you can measure the difference in voltage created across the two half cells. Just a differential voltage probe. So the difference is amps versus volts. And then again, for all of these, you just want to make sure if it's an analog tool, you're recording it to all of the ones you know, plus one that you estimate in between the lines. If it's a digital tool, you want to make sure you record all of the available measurements. We will talk about manipulating significant figures, and we'll talk about uncertainty when we get to tool 3, which is all about mathematics. But right now, we just wanted to focus on recording those measurements.